Hi, welcome to Lesson 7 of CSEC Physics at Edu Solutions Institute. Now, last week's lesson was about the types of forces, where we looked at forces such as frictional force, tension force, elastic force, gravitational force. Now, today we'll be focusing on the gravitational force, and specifically it is to distinguish between what is weight and what is mass. Now, mass, they are the particles in an object. So the small particles that make up objects are called mass, right? So mass is those particles within the object. It's measured in kilograms as its SI unit. Now, weight, on the other hand, is the effect of gravity on objects' mass. And what this means is, when gravity is pulling down on objects, it reacts with the mass of those objects to generate that force called weight. So we know that weight is a force, and it's always acting downwards. So it doesn't matter where the object is, its weight will always be acting downwards, because that's where gravity is acting, down towards the center of Earth. Now, how do we find weight? Weight is equal to the mass of the object multiplied by what we call the gravitational acceleration, which in symbol form, W is equal to m times g. Now, on Earth, the g there is a constant, which is 9.8 meters per second squared, but we will use always 10 meters per second squared at this level. So on Earth, gravity causes objects to accelerate at a rate of 10 meters per second squared. So therefore, if we find the weight of an object that has a mass of 5 kilograms, then it's 5 times 10, which will give us 50. And because we know that weight is a force, the unit of weight is 50 newtons. So therefore, the mass of this object would be 5 kilograms. But the important part to distinguish between these two terms is, what if this same 5 kilogram mass goes, let's say, to the moon? So let's say it goes to the moon. Now, the important thing to note is that the moon G is way less than the G of Earth. It's roughly 1.63 meters per second squared. And hence, we note that if this mass comes on the moon, it will still be the same mass. It still has the same amount of particles in it. So the mass doesn't change. But if we notice, the weight is going to change because the G changes. So the G moves from a 10 to a 1.63, hence the G will be less than 50 that it goes on Earth. The weight, will be less than 50 newtons when it was on Earth. So what this tells us is that the weight change based on which planet or which body you're actually on. So therefore, the weight of objects will change if the gravitational acceleration changes. And to change the acceleration, then you have to move from Earth to a next point, right? So in this case, we go on Earth, and then we move to the moon, where G becomes less. So therefore, weight changes due to the value of G changes, but the mass does not change. The only way you can change the mass of objects is if you add mass to it or you take away. Meaning, if you have your marker, if you take away the cover from the marker, you're taking away some mass from it. Right? If you want to add mass to it, you will probably take these two markers together, hence you get a different mass. But this object, once it remains as this object, will not change its mass because it will have the same amount of particles in it. But if you take this marble on Earth and put it to the moon, the weight will change because the gravitational acceleration falling, causing things to fall on the moon is way less than it was on Earth. And that's it for the end of lesson 7, where we looked at weight versus mass. Hope this clarified the definition of both and it clarifies how they are different. And I'll see you next week when we continue with our CSEC Physics syllabus. Thanks for watching.